A kite that transforms wind into energy, a vacuum cleaner that pulls CO2 out of the air, and drones that plant trees. Digital innovations that combat climate change. Our topic today on Shift. To limit global warming to a maximum of 1.5 degrees Celsius, greenhouse gas emissions must be nearly halved by 2030. This is what the Intergovernmental Panel on Climate Change has recently reported. The consequences are huge forest fires, melting polar ice caps, and devastating floods. Only by consistently avoiding using oil, gas, and other fossil fuels can we stop the trend. Or could digital innovations help humanity? Some of them sound too good to be true, like the CO2 vacuum cleaner.
Near Iceland's capital, Reykjavik, a plant that actively removes CO2 from the air has been operating since 2021. The technology behind it is called direct air capture. 8 collection tanks extract the carbon dioxide with high-tech filters and fans. First, they use heat to separate the carbon dioxide. Then it is mixed with water and injected deep into the earth. There, the carbon cools and solidifies, and no longer contributes to global warming. The plant is the largest of its kind and can capture and bind 4,000 tons of CO2 per year. But it needs a lot of energy. Iceland is an ideal location because it has both hydro and geothermal resources. Renewable energy is abundant and cheap here. It's the only sensible way to run the plant.
We are committed to use only renewable energy, so we don't want to emit CO2 while capturing CO2. The plant we have in Iceland, its efficiency is higher than 90%, which means that for 1 ton we are capturing, we emit about 10%, so we emit about 100 kilos.
Climeworks' first direct air capture plant went into operation in 2017. At the Swiss site, the CO2 was not stored in the ground, but used as fertilizer in nearby greenhouses. This closes the carbon cycle and prevents more carbon dioxide from entering the atmosphere.
An impressive approach, and it really works. But how much influence can it have on global warming? The plant on Iceland can capture as much CO2 in a year as 250 citizens in the US consume. Similar projects, such as storing CO2 under the ocean floor, have only had limited success, says Ajay Gambhir of Imperial College London.
A much older set of technologies called carbon capture and storage, which don't suck the CO2 out of the atmosphere as such, but actually capture carbon dioxide from the combustion of fossil fuels in things like industrial manufacturing plants, in coal and gas-fired power stations. And that carbon capture and storage technology has been a bit of a disappointment in terms of the rate at which it's been able to be piloted, demonstrated, and scaled up.
Industrial CO2 filtering plants can therefore only stop the rise in global warming to a small extent. So let's take a look at a completely natural method, photosynthesis. Plants grow using only light, water, and carbon dioxide. Forests are especially effective at removing CO2 from the air, according to German climate expert Julia Pongratz.
From all the so-called natural solutions, forests are the ones that probably have the largest potential. This is simply because it's large areas that potentially could be afforested, and forests have a rather high carbon density, so a lot of carbon per square meter.
But every year, around 15 billion trees are cut down worldwide. This is for firewood, or because the land is needed for agriculture, new roads, or settlements. Grasslands and deserts continue to spread. This contributes to global warming. At the same time, climate change helps create even more grasslands. It's a vicious circle. In Spain, rangers are trying to stop this trend using drones. They want trees to grow here again. In only 2 days, they have spread around 500,000 seeds. In India, the startup Maruch Drones wants to use similar technology to plant 1 billion trees by 2030.
The seedcopter plants trees from the air. The drone selectively spreads seed balls over areas to plant new forests or to strengthen weakened forests. A drone can carry 10 kilos of seed balls, each holding 4,000 to 5,000 seeds. This technology offers new opportunities for reforestation, says Suraj Petty, co-founder of Maurit Drones.
India is a very varied geography and terrain, like deserts in Rajasthan, the tarais in Uttarakhand, or mangroves in West Bengal. So there are many regions where people are unable to reach. So there are not many activities that are going on at present. Seedcopter can reach these areas, unreachable areas, with ease.
Before sowing, the drones survey the terrain. Afterwards, the seedcopter continues to work. It monitors the seedlings from the air, and the results are collected in a database to ensure healthy forest growth.
So once the imagery is taken, we run some specific algorithms which can process this imagery to create optimum understand optimum environmental parameters for maximum plant growth. So based on this information, we understand which parts of the forest needs to be taken care, where there is thin or very low growth of tree cover, and also what is the optimal seed ball configuration that needs to go in.
Artificial intelligence is decisive in monitoring the afforestation efforts, but it can take up to 40 years for trees to grow and actually sequester CO2, according to green IT expert Chris Adams.
They talk about planting a ridiculous amount of trees, as in the area of India to meet one company's carbon emissions, rather than just actually get off fossil fuels. So these can sometimes end up having the unintended impact of being a distraction from much more important conversations about decarbonization.
If we are to stop global warming, we cannot simply keep burning fossil fuels such as coal, oil, and gas. But where will our energy come from then? Could you imagine life without electricity? For nearly 800 million people worldwide, that's the reality. Most of them live in sub-Saharan Africa. Sierra Leone in West Africa is one of the least electrified countries in the world. Only 23% of the population has reliable access to electricity. Intelligent solar networks are set to change all that.
Solar panels have changed life in Tikonko, a village in Sierra Leone. There is finally reliable power from renewable sources, a great improvement for the people here.
I dey use the lights because pikin dey get for study panel. Then I dey use television, freezer, and fan. It don't contribute, but good thing in my life. It don't make. I dey do my business common because some people then the way they carry the drinks them cold. Now I dey car for can buy.
This community's solar-powered mini-grid is designed to solve two problems at once. First, provide much-needed access to electricity. Second, reduce greenhouse gas emissions through renewable energy. The decentralized energy system works in remote areas off the national power grid, and intelligent control systems are able to capture any superfluous energy. The PowerGen company installed the microgrids. For manager Mohamed Saleo Conte, it's a promising concept.
This community, 5 years down the road, it was completely dark. But now, today, we have electricity here. For me, going forward, for the rest of the world, this is a very good and viable option.
Are microgrids or local solar energy grids really a global solution? We asked energy expert Murefu Barasa from Kenya.
Microgrids are not the be-all, end-all silver bullet that will solve everything, but they are an integral part of the electrification process in the global south.
Like, for example, the solution found by Dr. Amit Singh in the Indian state of Rajasthan. He has installed solar panels, both on his hospital and on the family farmland.
I feel like I'm contributing to the needs of my village. Kotputli needs 220 megawatts, and I'm generating 5 megawatts here on my land. So I am contributing to 2% of my village's power needs. I feel good about that.
He regularly feeds solar energy into the local power grid. Individual projects which utilize AI can provide local relief. But other solutions are needed to meet the rising global demand for energy.
There needs to be an understanding That is not centralized grid versus smart microgrids or versus standalone solutions. It's really what's the best solution within each context.
The German company Enerkite has an innovative and decentralized way of generating energy. It uses the power of the wind. There are no huge wind turbines, but instead a mobile system.
The portable system consists of only 3 main components: the stunt kite, the control lines, and the steering cabin. The kite is flown automatically, with prevailing wind conditions being taken into account. They fly higher than the tops of existing wind turbines.
Enerkite uses the wind up high, where it blows strongly and consistently, above today's wind turbines. It uses high-technology kite systems that are controlled from the ground and transmit the wind power via the lines to a generator on the ground.
The kites are designed to generate twice the power of conventional wind turbines.
Only the small turbine blade tips are actually effective. We've reduced our system to that and replaced the stability of steel and concrete with a very reliable control system.
The costs for solar and wind energy and for batteries are sinking. They're down 85% since 2010. But time is running out. We must act now and make more use of modern energy technologies. The IPCC has warned that we have only 3 years to reverse the trend in greenhouse gas emissions. There are innovations. However, the technologies we have seen today are only a small part of the solution. The CO2 vacuum cleaner won't help if we still burn oil and gas. What have you done to tackle climate change? And which technologies do you find the most promising? Tell us on YouTube or at dw.com. Bye and see you next time.